This is lesson 8.6, natural logarithms, and today we're going to focus on this idea of a natural log. You've already seen log properties and solving with logs, and today we have to remember what the letter E is. That's going to be important for us. So the letter E is an irrational number when we have it here in Algebra 2, and on our calculators we can plug in second ln to get your E key, and it's approximately 2.718. And again, you can use your second ln key to get there. And when you have an exponential function where E is your base, then when we convert that to log form, this is log base E of y equals x. But instead of writing log base E, we write ln. So ln of y equals x. So don't write it like this. Write it instead ln of y, and this is what we call the natural log. There's another type of special log. If you think back to our first lesson on logs, section 8.3, we said that not only does log base E become natural log, but log base 10 just becomes plain old log. So if you look back at that section, it talks a little bit about this as well. But today we're going to focus on what rules and what properties work with the natural log. And the good news is that all of the log properties that you've seen so far apply to natural logs the same way. So for example, when you're asked to write logs as a single log, the same rules about powers in front. So here's a power in front. Comes on top of the 12. So you have ln of 12 squared minus ln 9. This is the same as ln 144 minus ln 9. And when there's a minus between two logs, remember that's your quotient property. And this was section 8.4 that we learned this in. Your quotient property states that it's the single log of 144 over 9. And when we simplify that, we get ln of 16. All right, here's another one that has a power. Move the 5 onto the 2. So this is ln of 2 to the 5th minus ln 4. So this is ln 60, no, what is this one? No, 32, excuse me. So this is ln 32 minus ln 4. Again, it's quotient property, so this is ln 32 divided by 4, which will be ln of 8. And then our power here is going to move on to the y. So this will be ln x plus ln y to the third, which is ln x times y to the third. Okay? So all the quotient, product, power properties, all the same. Other things that are the same are when we solve. Now for our solving section here, it's helpful for us to remember our conversion, that when we have log base b of y equals x, this converts to y equals base b to the x power. Remember we talked about that base like comes up underneath the x, or that base comes over here in front of the y. And when you switch from side to side, you either remove the log or insert the log. But that's your conversion formula. You need to make sure that you have your log isolated. All these solving things are going to be the same as section 8.5 with your logs. When it's isolated, then we can convert. This base here, even though it's not written, is base E. So if it helps you to think about this being log base E of x equals 0.1, that's fine. You can think that. I'm going to go ahead and move right away saying this is E, so x equals E to the 0.1. This is my exact answer. And for my approximate answer in my calculator, x is approximately 1.1052. Next example that we see here, this log is also isolated because the parentheses keep it all together. So again, the base is e. So I'm going to bring the base over, so e to the fifth. That removes my log, so it's 3x plus 4. So 3x plus 4 equals e to the fifth power. I need to minus 4 from both sides, so 3x equals e to the fifth minus 4, and then divide both sides by 3. So x equals e to the fifth minus 4, all divided by 3. And in the calculator, make sure that you use parentheses to include both of these on the top there. And this one comes out to be about 48.1377 as the approximate. So again, here's the exact, and here's the approximate. All right, now in this example, this part is the log. The 1 is not included inside parentheses, so we do need to move that 1 out of the way. So let's make a note. Isolate the log before you're allowed to convert. So minus 1, minus 1. So ln x squared equals positive 1. This is log base e, so x squared equals e to the first. I need to undo that squared, so I'm going to square root both sides, remembering my plus or minus. Remember this little guy? Pink, right there. So x equals plus or minus square root e, which is approximately plus or minus 1.6487. So my exact and my approximate. And then the other half of this type of problem is when you start with the base. So here we have y equals some base of x. And the conversion form here is that we will get log base b of y equals x. The same formula we had on the other page, but this time we're starting on this side, and we'll have to convert to a log. So again, I have my e to the x isolated. Move my e over. I could think inside my head that this is log base e of 15, but again, we don't like to leave log base e there, so I'm just going to go ahead and write ln for log base e, 15. There's my exact. Your ln key on your calculator is next to your 4, and so x is approximately 2.7081. For this next one here, we have to isolate the e. So let's make a note. Isolate the exponential expression. Which means that we're going to have to add 8 to both sides before we can keep going. So e to the x over 9 equals 14. Now we can convert. So when the e comes over, we have x over 9 equals ln 14. We need to multiply both sides by 9 to cancel that 9 on the bottom. And now here is what this is not equal to. This does not equal ln of 126. So many people will want to multiply the 9 and the 14, but that is not true. This 9 cannot go into the 14. This is a package deal. This is ln 14. On your calculator, this tells us it's about 2.6. So we're saying 2.6-ish times 9. So that is not the same as multiplying this 9 inwards. What you can say for me instead is x equals 9 times ln 14. 9 times that package deal. And then when we plug this into our calculator, we get about 23.7515 as the approximate. All right, here's another one where we need to isolate. So to isolate, make sure that we move this 1.2 over. So 4 times e to the 3x equals 12.8. Divide both sides by 4. So e to the 3x equals 3.2. Now we're ready to convert. So I'm going to move the e over. 3x equals log base e, or natural log, 3.2. Divide both sides by 3. So x equals ln 3.2 all over 3, or x is approximately 0.3877. And there you go. Different things you can do with natural logs, all the same as what you do with your other logs.